Hi, this is Mrs. Carnes, and this is the video that's going to talk about compound inequalities that contain the word OR. So compound inequalities are going to be two inequalities that are joined by this time the word OR instead of AND. And now in this case, we're going to talk about a solution to a compound inequality is any number that will make either of the inequalities true. Last time it had to make both of the inequalities true. This time it's either one of them, one or the other. Let's take a look at an example. So in this compound inequality, we notice that it is two inequalities and they are joined together by the word OR. So we don't really have to rewrite each inequality as we did with the AND compound inequalities, but it helps to just have them rewritten so that we can begin solving them and we can see what we're really talking about. So the first inequality is that 4v plus 3 is less than negative 5. When we use our inverse operations, we're going to subtract 3 from both sides. We get 4v is going to be less than negative 8. And we divide by 4, and we get v is less than negative 2. Notice that the inequality did not flip because we did not divide by a negative number. Now, the second inequality, again, which is already written out for us, is negative 2v plus 7 is less than 1. And when we get v by itself, we subtract 7 from both sides. We end up with negative 2v is less than negative 6. We divide by negative 2 on both sides. Again, those bells and whistles are going off in my head, reminding me that when I divide by a negative number, my inequality must flip, and I end up with v is now greater than, and negative 6 divided by negative 2 is positive 3. We bring down our OR, and we would have this as our compound inequality solution. And so let's go ahead and take a look at what this means. We know that values that are less than negative 2 would be solutions, or any value that is greater than 3 would be a solution. So let's take a look at what this would be on a graph. So to graph this, again, we're going to look at each one separately at first, and then we'll go ahead and combine them onto one number line at the very end. So v is less than negative 2 would be an open circle at negative 2, and you would go less than that. You would go to the left to get less than negative 2. The second one is v is greater than 3, so you would have, again, an open circle at the 3, and you would have a line going to the right to be greater than that. Now notice in these graphs, they never overlap because they're not an AND compound inequality. Only the compound inequalities that deal with the word AND would overlap. So in this case, our final answer, when we put it on a graph, on one graph, we put both of them on the same graph, we're going to end up with two lines going in opposite directions. You'll have negative 2 going to the left, and you'll have 3 being greater going to the right. And that would be the final graph for that compound inequality. Remember, if you need to go back and take a look at both of these together, the AND compound inequalities and the OR compound inequalities, feel free to watch either of those videos over again to make sure that you are understanding all of the details.